All right, guys, week 15. And this week, I won't say jammed packed, but we're going to have 2 lessons each day. So actually 4 lessons we're going to go over and cover in this video. So we're starting in lesson 115, 116. That's one day, and then 117 and 118. So we'll go ahead and get over in our book. We're looking at 115 first. Okay, and this is factoring algebraic expressions. So what is an algebraic expression? Things we've been really working with all year. Not just a constant or a number, but something that has a variable or an unknown attached with it. Quick review of monomials. Again, just one expression, even if it has division or it's just a number. Okay, this isn't being added or subtracted to anything. So all of these are examples of monomials. Again, mono, one. Binomials are really poly, which just means many, which is just more than one, is anything that's not a monomial. So this, we have one term plus another term, so that's 2, so that's a binomial, but we could also categorize it in broader terms as a polynomial. This, we have 1, 2, 3 terms, so trinomial, and again, all of these are examples of polynomials. So in looking at these, we're looking at things that we can factor out. And we'll do this because down the road it'll help us when we're reducing or simplifying or even solving for some of those things. It'll make it a little bit easier for what's going on. When we're factoring something out like this, for example, well, we know 6 we can factor, do our prime factorization. It's 2 times 3. X squared is x times x, y cubed is just y times y times y. Looking for the greatest common factor of the polynomials. We have 3x squared y. We first find the greatest common factor. We have 3x squared y, 6x squared y. So we get 3x times y plus 2 times 3 times x times y times y. So when we're factoring those out, we can divide both of them by what? Well, 3 goes into 3 and 6, so we can factor out a 3 from both. X squared and x, well, we can't factor out x squared because that wouldn't work here, but we can factor an x out. And then we have a y and a y squared, so I can factor out a y. So breaking it apart will help you kind of visually see what you're able to factor out. That will help you. Let's look at example 1. So I have 12 a squared b cubed c. So this one we're not adding or subtracting or dividing by anything, so we just want to rewrite it in a form that it's completely broken apart. So 12 I can do, if I do my prime factorization, 6 times 2 and 3 times 2, so I'm going to rewrite that as 3 times 2 times 2. A squared is a, symbols, b cubed, b times b, and then just c to the power of 1, so just one of those. So I can rewrite it like that. For this, it doesn't really help us to get broken out like this, but when we're adding or factoring or trying to simplify or multiply, it'll really help us to understand what's going on here. So if we look at example 2, and we want to factor this trinomial, again, factor out means we've got to find something that goes into all 3 of these terms and factor it out or divide it by it and put it outside a set of parentheses. So let's first rewrite it. And down the road, you guys will get really good at this, where it just becomes second nature, and you see it right as what you can factor out right as you look at the initial polynomial. So again, trinomial, I have 1, 2, 3 terms, so it's 3 trinomial. But let's first look at our coefficients, 6, 4, and 2. I don't know about the A's, B's, C's, anything like that. Just our coefficient, our numbers. 6, 4, and 2. Oh, they're all even, so I know 2 goes into all of them. So I'm going to factor out a 2. Okay. Now let's look at our A's. I have a squared, a, and a. So I can't factor out a squared because these are not a squared, they're just a. But I can factor out one of those, a to the power 1, and then I have b squared, and b. So I can't factor out the b squared, but I can factor out a b from both of those. Now let's rewrite what's left in here. So if I divide 6 by 2, I have 3 left. A squared divided by a means I have a to the power of 1 left. B, we can write this as 3a to the, not to the power, but 3a times 1, which is just 3a. So don't put 1 here thinking it's 31a or something like that. If it's 1, we'll just factor it out. We don't put 0 either because that would make all of this 0. So it's just 3a. We factor out 2ab. Plus 4 divided by 2, I have 2 left. A divided by a is just 1, so 2 times 1 is just 2. So just leave it as 2. Factor a b out of b squared, so I still have b to the power of 1. Okay, factor out 2. You can write in the 1 for the coefficient if you want to. You don't need to. Okay, and then I factor out an a and a b. So in this case, actually, we do need to write in the coefficient because it's actually a constant right here. So if I factor out 2ab from 2ab, I have 1 left. I can't just leave this as nothing or 0. So when I distribute it back in here, 2ab times 1 is 2ab. If I put in 0, 2ab times 0 is 0. And again, a way you can always check your work, I know for this one it may be time consuming, but you can distribute it back into your polynomial and make sure that it works out to be the same as where you started. And you don't want to do that every single time, but early on, if it's a test or something like that, you want to be 100% sure that you did it correctly. Well, distribute it back in because, again, we're not changing this. We're just rewriting it in a different form or factoring something out, but we shouldn't be changing the value of our polynomial. So if we did 2ab times 3a, that'd be 6a squared b. 2ab times 2b would be 4a squared, yep, and 2ab times 1 would be 2ab. So it would work out to be the same. I know we did it correctly. All right, we'll go over these in class as practice set together. Next lesson we're looking at, second one for the day, is lesson 116, slope-intercept form of linear equations. So again, slope-intercept, it goes back to, and I believe, this is on your reference sheets. Yeah. On your reference sheet, and it may be hard to see here. Okay, slope-intercept form. So linear equations, we have point-slope form, which is way down the road. Don't worry about that. We have standard or general form, which we've worked with that a little bit this year. We usually plug in 0 for x, solve for y, 0 for y, solve for x, and there's 2 points. That's all we need for a line. And then we have this one, which is probably the most common, which is slope-intercept form. And what the different m and b and what all those represent. So y equals mx plus b. Well, m, why they chose m, I'm sure there's a really good reason behind it, but that doesn't mean multiple or anything that starts with an m. It actually means slope. That's where you get slope-intercept. That means b is our intercept, our y-intercept, or where the line crosses the y-axis. And again, at some point it's going to have to, unless it's a straight vertical line, which does not pass the vertical line test, so it's actually not a function. So it's got to cross the y-axis somewhere. So slope, intercept, plug in for x, it's going to give us slope times x plus b, it's going to give us a value for y. And this is really the best form to work with, at least in my opinion, because then we can just go right into our y equals in our calculator and input an expression. So if we look back at this, okay, let's say this is our standard form. We have -4, so we add 4 to both sides. 2x plus y, so I subtract 2x from both sides. So we can manipulate from the standard form and get to the y equals mx plus b form. Not too difficult. We just do it so everything is on the right of everything but y is on the right of the equal sign. and then we can keep it in that form. Okay, so again, slope, as we talked about previously, is rise over run. So again, rise over run. Let's say we start here. I go up 1, 2, 3, 4, and I go over to the left 1, 2. So it's going to be 4 divided by -2. 4 divided by -2 is -2. But once we have that slope-intercept form, we don't have to pick points on our graph and do the rise over run. We know automatically in this form, this is our slope. We just showed that it was our slope, but it's easier just to be given up. -2x plus 4, well, this -2 is my m, my slope, so there it is. The slope is -2. The y-intercept, well, it's plus 4. You can go look at the graph. Well, here's my y-axis, so I go up 1, 2, 3, 4. That's where it crosses. So that's our y-intercept. And once you have it in this form, you really know your slope and your y-intercept, and most of the work is ready to go from there. As we talk about slope and intercept, and that's the form I just showed you. Write it down, but it is on your reference sheet. So if you ever forget slope-intercept versus standard form, what's the difference? Just look at your reference sheet. That's what it's there for. And so if we have this 3x plus 6, or sorry, plus y equals 6. So this is not slope-intercept form, but we can get there not too difficultly. Well, get rid of this 3x and minus 3x. Now, when you do this, obviously it's better. Okay, we can do 6 minus 3x, but that's kind of the opposite of our mx plus b form. It's not incorrect, but better would be, okay, this is -3x, so let's put that out front, because we usually write all of our equations, even this linear form, in descending order. So anything with a variable to the highest power, so this is an x to the power of 1, and then we have a constant, which is a positive 6. So -3x plus 6. It's 6 minus 3x. Yes, that is the same, but this way is just better because it's already in the variable. It's supposed to be 4. So this is our slope. Rise over run that gives -3 at any points we choose on our line. And then it's going to cross the graph at positive 6. It's going to cross the y-axis at positive 6. Okay, and then once we have it there, example 2 wants us to graph it. Okay, we could do our y table, 0 for x, -3 times 0, 0 plus 6. Okay, that's our x. That's our intercept for our y-intercept. 1, -3 times 1. That's -3 plus 6. -3. Okay, and we could do that. Nice thing about, like I said, when it's in y equals mx plus b form, we can just go to our calculator. We have so negative. Is this negative sign down here? -3x plus 6. Get that? We graph it. Okay, it's a negative slope, so from left to right, that's why it's going down, because of the negative slope. Okay, our y-intercept is 1, 2, 3, 4, 5, 6 right there. We could zoom in and verify that. We could also go to our table. So if we were asked to find 3 points, this is why I showed you in the past, find 3 points that fall on this line, or 4 points or whatever. I graph in the calculator y equals mx plus b form. Then it's just a matter of, really, you have infinite points that you can pick. We did 0, 6, we did 1, 3, we did 2, 0, 3, -3, and so on. So we keep going on all the way. The positive thing would be we can go past where x equals 0 and make x negative and find points all along there. So this makes it really easy. Once we have it graphed in the calculator, there's a lot of different things that we can do with it. So that's where y equals mx plus b form is really handy. Okay, so we did just graph that. Right, so again, we're looking at this. Here's our slope-intercept form. Now, if we don't have a coefficient out here, we know that it's 1. We don't have to write it in, but it's 1x is equal to x. So if there is no coefficient, it's 1. So that's our slope. Our slope is positive 1. Our y-intercept is negative 2. So we can go down below the origin, 1, 2. There's our y-intercept. And the slope of 1 means up 1 over 1. Rise over run. So up 1 over 1. Or up 2 over 2. Or up 3 over 3. And it's going to go 1 over 1, or 2 over 2, 3 over 3, 4 over 4, because it's always going to equal a slope of 1. Okay. Robert noticed a bird's nest in line with the slope of okay, I'm just trying to look at this. I was thinking this house is either really small or this person is really tall. Okay, but it's saying it's an for the house. He knew that the slope of the roof was 4 and 12. So they usually calculate or express slopes of a roof like 412. For every 12 inches, it drops 4 inches, or for every 12 feet, it drops 4 feet. That's the ratio or the relationship between the slope. He also knew that the edge of the roof was 8 feet high, and he measured 48 feet from the edge of the roof to spot directly under the nest. Then he calculated the height of the nest. How high was the nest? So it's following that same slope. So it's linear. That's what we need to know. There's some J shape or something like that. That wouldn't work. But it's linear with the roof. So we know the slope, right? Rise over run. The rise of 4, run of 12. 4 divided by 12 is 1/3. Okay, so we keep that going for 48. And so we use our slope, our y-intercept, which we're calling 8 feet high. So we're plus 8. This isn't just him, this isn't an angle from the ground. It's the angle from the edge of the roof, which is 8 feet. And so that's essentially our y-intercept. So we get to this equation, 412. So I would only reduce that to 1/3, but it's going to work out to be the same thing. For 412, 412, so 1/3 x plus 8. We plug in 48 feet. That's our x value. And our horizontal value, what's going to be our y value, or what's going to be our vertical value. We plug it in. 412, 1/3 of 48 is 16, plus 8 is 24. So that is the height. If everything, again, this ground is even and tree is straight up and down, and this is linear with it, we calculate. Right, we'll go over that practice set together. Lesson 117, we are copying geometric figures, and this one's going to be tough to do over videos, so let's just kind of follow along. So we went over some of this. We don't really do the investigations, but we've talked about some of this. So for these, you're going to need a compass, a straight edge, and some other tools. If you don't have those, you may have some in class. It's just bear with us. It's not the end of the world. Don't go out and buy anything that you don't have. Just pay attention. So we can use a compass and straight edge to copy figures. So we set the radius of the compass to match the length of the segment. So it's a polygon. We're looking at one of the sides. It's a line segment. It has a beginning and end. So we take the compass and we match it. We draw a dot to represent one endpoint of the new segment and swing an arc and make this shape. It's an arc because it's going to make, we're going to go all the way around and we make a circle. So this little section is going to be curved. Arc from the dot. Set the radius of the compass to match the length of the segment, then draw a dot and swing the arc from the dot using the compass setting. Okay, so draw a segment from the dot to any point on the arc to match the length of the original segment. Now suppose we're asked to construct two parallel lines that are the same distance apart as another pair of parallel lines. We use the compass to find the distance. Okay, so the compass swoop through, touch a point at the outer edge of the arc. We use a setting to mark the distance between the copied lines. Set the compass to match the distance between the original parallel lines. Draw a line, then use a compass, swing arcs from any 2 points to draw the line. So just pick 2 points arbitrarily wherever we want. We swing the arc, make sure this distance is the same, and then draw a line through those two, and they're going to be parallel. Okay, copying an angle. Okay, here's our original angle. We sweep through. Okay. We figure out this distance right here, and then we sweep through that way, okay, and then we do. I'm not sure if I'm the same. Okay. So yeah, from this vertex right here, we draw a compass and swoop through. So we would do that same distance right here and swoop through. For the second step, we reset the compass to equal the distance from A to B. So from A to B in our original, now A to where we want B to be here, and we swoop it through. So we know that's going to be that point where they cross. The line has to go through that side or whatever this vertex goes to, whatever polygon it is, or if we're just copying an angle, we know it goes through and it's going to be the same. Triangle, you're going to do the same thing, basically what we just did here, but now we're going to have more than just one vertex. We're going to have 3 vertices. So we go out to y, x to y, x prime to y prime, and swoop it to make an arc. Okay, then we go from z. We need to draw 2 different arcs, from one from x and one from y. So then we would go x to z, y to z, draw your 2 arcs where they cross. Okay, that's going to be vertex z. That's where z prime is going to be. Okay, and we'll do the same thing for all of them, and we end up getting our 3 vertices, and that's our new triangle. So this one, I don't quote me on it, but I don't think I'm 99% sure we won't have any test questions that deal with this. Obviously, knowing about congruent and similar figures is the most important. It may be helpful to know how to copy them or transpose them and make them identical separately. But if there's ever a test question that says use your compass or your protractor or something like that to create anything, I know you guys, not all of you have that, and it wouldn't be provided on the test, so I would just throw out that test question. So I'm not saying this is unimportant and to not pay attention or know how to do it, but the grand scheme of things and what we've been learning, if this one isn't making 100% sense, we'll go over it more in class, but it's not the end of the world. We're artistic, we like to draw things or copying them and know how to do this, and that's great. If this, as long as you know the properties of polygons and angles and things that we've talked about, that's the most important. All right, lesson 118, our last one for this week is division by 0. Now, actually, we cannot divide by 0. So I know we talked about a little bit, or had you guys, sometimes we get a problem where we get an error, and that's not necessarily because we did something wrong. We just have some examples in mathematics where we have no solution. So sometimes we get, as we've learned about, more than one solution. Sometimes we don't have the possibility of any solutions. If we're looking at 2x over x, well, normally x over x is canceled out to be just 1. 2 times 1 is 2. That is true. Nothing's changed with that. But we say it cannot be 0 because I can't have 0 in the denominator, because that would be 2 times 0 over 0. Any number divided by itself is 0. Or sorry, is 1. Yes, that's true. Oh, let me go 5. We've said that 5 divided by 5 is 1. 9 divided by 9 is 1. 0.01 divided by 0.01 is 1. So that's true all the time, except for 0. That's usually we have all these rules that apply to all numbers from from all the integers from 1 to infinity, -1 to infinity, but 0, a lot of times, not always, but it's our rule breaker. So like 0 divided by 0, we say, well, any number divided by itself should be 1. That's true except for 0. We get an error message because we cannot divide by 0. In error, it's not necessary that you're wrong. You may just have a problem that has no solution. In this one, we could put in any number except for 0. So we put in 1 for x, okay? 2 for x, 3 for x, 4 for x. We could even graph this. So if we were to graph this on the calculator, 2x divided by x. So clear this out. 2x divided by x. Let's take a look at that. Okay, it would be linear right there. Well, let's look at a different thing with that x. No, let's look at an inverse example. Let's say 10 divided by x. So we know inverse relationships, direct variation is whereas x gets bigger, y gets bigger at the same rate. Inverse variation is x gets bigger, y gets smaller. So this is an example of that because as I divide by 1, 2, 3, 4, 5, 6, let's take a step back before we. So let's use our 10 examples. So 10 divided by 1 is 10. 10 divided by 2. As this number in the denominator is getting bigger, what's happening to our solution, or our quotient, is it's getting smaller. Okay, it keeps getting smaller and it'll do that. Now let's divide by a number less than 1. Let's see what happens. So 10 divided by 0.5. 20. Okay, so the solution actually got bigger. 10 divided by 0.01. 1,000. Maybe 10 divided by 0.0001. Okay. It's now getting bigger. So as this number gets closer to 0, smaller in the denominator, this number is getting bigger. And so that's what we're working with when we have this 10 divided by x. So let's graph. Okay, we get these asymptotes right here in the first and the third quadrant. Now, as we notice, we look like, it looks like it's going to eventually cross the y-axis. Well, is it? Okay, it's going to get infinitely closer to these axes, but it's never actually going to touch or cross them. And we'll show you why. So if we go into the table, okay, y equals 10 divided by x. When I put in 0, I get an error. Why is that? Okay, well, I can't calculate value. There is no value here for y where x equals 0, because where x equals 0 is right here. It's not to the right or the left. It's right here. So it's never going to cross that y-axis. So x can never be 0 because this graph, even though it looks like it, and it is, it's getting infinitely closer, but it's never actually going to touch the y-axis. Same thing down here. It's going to continue to drop and get closer, but we could take it out all the way out to where y is, where x is, y, take it all the way down to where y is like -1,000,000 or something like that. It's going to look like it's very, very close, and it is, but it's never actually going to touch it. All right, so if we look at these examples, some of the ones we just used, 10 divided by 1, 0.1, 0.001. So as this number gets smaller in the denominator, the solutions get bigger or further from the origin. It's the same property if we use negative numbers as well. So +1 was 10, -1 is -10. So they're still getting further away from the origin. All right, so this is just talking about fact families that we have. So let's say we know 5 times 3 equals 15. 3 times 5 equals 15. 15 divided by 3 equals 5. 15 divided by 5 equals 3. So we have all of these this fact family, but with these three numbers, we can make all of these facts. But one time again, if this doesn't work, is when we have 0. True so far. I should be able to say 0 divided by 5 is 0. So divided by 5, yeah, still checks out. But then let's do where we flip these just like we did. 5 divided by 0 is actually an error. It's undefined, so it does not equal. So again, those fact families that we can use for any three numbers, we should say any three numbers except for 0, so it doesn't work out to be true. So they use 2 and 0. 2 times 0 equals 0. That's true. 0 divided by 2 is 0. That's true. 0 divided by 0 does not equal 2. That is not a fact. So we can't create those fact families with this. If we have an expression like this would be inverse relationship. As x is getting bigger, y is getting smaller. Hey, but it's 3 plus x in the denominator. So x can be 0 because 3 plus 0 is 3, so it can still be 0, but it cannot be negative 3 because 3 plus negative 3 is 0. 12 divided by 0 is undefined. So we would not be able to have x equals negative 3. Right, so you cannot divide by 0, but we will have some examples where we end up where we have to divide by 0, and we would say it's undefined, or there's no solution, or what I usually do, like, we can say x can equal 0, or if we get a problem where we get an error message because we had to end up dividing by 0, then we just say it's undefined. I just do the 0 with the slash through it. That just means that it's impossible. You can't do that. You don't have to write out error or whatever your calculator says. You can just use that symbol. All right, we're getting there, 119 and 120, and then that's it for our book. See you guys in class. So just 115 through 118 this week.